2.7. Let's do problem 1a together. So we're going to need to describe the motion in a table for each of our problems, just so we can keep things straight. So the initial position, initial means at the beginning time. We're going to split this up into two segments. So for segment 1, which is right here, initially the position is 0 kilometers. The final position is 40 kilometers. The time interval is the final time minus the initial time. So it'd be 45 minutes minus 0 minutes, and that's 45 minutes. Time interval. Is the speed constant? Well, there's just one slope, so yes it is. And it's slow compared to the other one because the slope is not as steep, but it's definitely in the positive direction. Let's do segment 2 in green. The initial position here is where we left off for the first one, at 40. And our final position is at 80. The time interval is the final time minus the initial time, so it'd be 60 minus 45 minutes, that's 15 minutes. It's just one slope, so yes, it's constant speed, and it's fast compared to the other one. And it's still in the positive direction because the slope is positive. Describe in words the motion represented in the graph. Well, it starts at 0 position, going in the positive direction at constant slow velocity, then speeds up. Well, it doesn't really speed up, it just starts moving faster instantly, which doesn't really happen in nature, but it's in the problem. Alright. Draw the quantitative velocity versus time graph. So this is a VT graph. Now I need to make this quantitative with numbers. So let's go ahead and calculate the velocity of each segment. Velocity is change in x over the change in t. The final position is 40 kilometers. The initial is 0. Final time is 45. The initial is 0 minutes. And so I'm going to get 40 kilometers over 45 minutes. That's 0.8 repeating kilometers per minute. Let's graph that. You should have 0 in the 0 line. Below the 0 is the negatives. Above the 0 is the positives. And I want to come in right below 1 to plot this. This is positive 0.8, so it's going to be right there. But how long do I hold that? Well, I need to graph time now. So this will be 15 minutes. This is 30 minutes. This is 45 minutes. And this is 60 minutes. Put my labels on it, just like it asked me. And the velocity would be, okay, there's my velocity, kilometers per minute. And I want to hold this velocity, it stays constant until the 45th minute. right there. Let's calculate the velocity for segment number 2. Velocity is rise over run. So it rises 45. I'm sorry, rises final is 80 minus the initial is 40. And the final time is 60. The initial time is 45. So I'm going to get 40 kilometers over 15 minutes, which is 2.6 repeating kilometers per minute. And we can graph that between 45 and 60. So this would be 2.5 there, and I'm going to be slightly above that. And here's my discontinuity. We know it can't happen in real life because it's x and the v graph need to be continuous. But there it is. And you can even see here, I'm going along nice and slow, and then I speed up. So what's the average speed? We're going to write it like this. The average speed is the total distance. Total distance over the total time. Well, I need to calculate the distances. That's distance, not change in position. So how far did I go the first segment? Well, I started at 0 and I ended at 40, so that means I went 40 kilometers. For the second segment, I started at 40 and went to 80, so I went another 40 kilometers. And how much time did it take me? Well, it took me 45 minutes for the first segment, and then 15 minutes for the second segment. So I'm going to get 80 kilometers in 60 seconds. And that will shake out to 1.3 kilometers per minute.